Hey everyone, Mr. Allen here. I just want to quickly kind of go over a little bit more of an introduction for your project options for the end of this course. You can see on your screen that we've got sort of four different options. I've kind of broken that first one, the stats project, into two parts because depending on which one you choose or which type of research you do, the expectations will be slightly different for the two. I'll tell you just kind of an overview here of the four of them, and then maybe off to the side. I'm not sure which side it'll be when you look at it. Up here, I think, is the way it's going to work. Hopefully, you'll see links to a little bit more specific breakdown of each of the different options so that if you have a pretty good idea which one you want to do, you can kind of check it out without watching the whole thing. If you look down here, I think you'll see that the video is probably pretty long, although I'm just starting it now. I'm just kind of guessing because I tend to ramble. So we'll sort of start there. A quick overview overall. I would suggest that number one here will be the one that probably will require the most extensive write-up. You'll start with a thesis, something you're trying to prove, or a question, something you're trying to find, and you'll go online and find data to support that. It'll be pretty quick and easy to get started on that. It's sort of the most traditional of the options available to you, and so it would probably be the one that would require the most of a write up at the end. The stats project, where you're collecting your own data, of course, would require a little bit more setup. You'll have to take the time to create the survey or to determine how you're going to collect your data, and so the write up that follows will be less extensive. And then the other two, basically, the write up will be whatever it's required for you to kind of cover the expectations. Now, in all four cases, I'll give you a little bit more detailed expectations of what to hand in a little later, probably by Wednesday or Thursday, because, of course, we've sort of got about 2 weeks to kind of get the whole thing done. So you'll be kind of working on setup for the first couple of days, and then I'll give you sort of a much more detailed explanation of kind of what I want submitted for each of the options. So So if you have something specific that you're thinking about already, you can again click, I'm assuming over here, unless I've got that backwards, in which case it's over here, whichever of the options you're interested in. Otherwise, you can kind of continue to watch each one and sort of see if there's one that kind of is of most interest to you. So project one, as I said, is just the one where you're going to pose your question or create a hypothesis or a thesis statement of some sort, and then go on the internet and try to find information to support that. So overview, pose an interesting question or create a hypothesis. Use sources on the internet to help find information to prove or disprove that. Things you want to consider while you're doing this, so kind of while you're going through, not the actual submissions here, but kind of as you're kind of getting going. While the main purpose of your project is to answer the question or disprove or prove your thesis, you do want to remember this is a math course, and so as you're finding data, as you're creating your thesis even, or asking your question, you want to kind of lean towards quantitative data or a question that will require quantitative data, so numerical values, over qualitative data. So something as simple as, if you were looking for information on the amount of sleep people get, if you can actually get the hours versus something like a good night's sleep or a limited amount of sleep or something like that, then you leave yourself open to doing better analysis later. And so kind of what I'm looking for here, or what I'm suggesting here, is things to think about while you're going through this. Make sure that the websites you're using are valid. Things like StatsCan, any universities, medical institutions, and of course, are all good. Wikipedia can be okay, except that when you go on Wikipedia, what you want to notice is whether the information that's given there has good sites to support it. If it does, if you happen to go on Wikipedia and find something of interest, and there's a second link there that says, hey, here's the information, here's where I got that information at the, at Harvard University or from Harvard University's website. Link to that site instead. Kind of go to that site, make sure you can kind of back up the same information and make use of it instead of Wikipedia itself. And then other sort of things, just sort of make sure that the data you're collecting kind of does pertain to your thesis question or your thesis or your question. If it doesn't, maybe, but you think it's good information, you can maybe tweak the question or the thesis as well to fit a little bit better. You may find that at some point that the specific way you worded things, you're not able to come up with the information you need, but that a slight variation on that question will be something that you can at least discuss moving forward. And then you're basically going to be looking to create graphs or tables to organize your data and to clarify your, sort of what you want to eventually summarize. Make sure that as much as possible they do pertain again to the information that or to the thesis question that you're starting with. Anywhere you have a single variable, a numerical variable, you're looking to determine whether you can do the calculations that we did in class. Central tendency, standard deviation are the big ones. So that's mean, median, mode, standard deviation. Of course, if they help your point that much, that's that much better. If they don't, it's still maybe better to include them than not include them entirely. And you'll sort of see that in the rubric as I set that up a little bit better later on. Two variable data. Basically what we saw there was we dealt with scatter plots, regression, and predictions. So of course if you can include something like that, again, all that much better. And then with respect to correlation versus causation, you just want to recognize that if you have a couple of different trends showing from the data, now this is again fairly advanced, you're talking about two sets of values that are being compared in scatter plots. But if there does seem to be a correlation between two sets of your data, you do want to recognize that there's a possibility at least that the correlation, as we saw in Unit 4, was kind of random. It just happens to be that way, and not that there's necessarily a causation effect that should be considered. Project 2, stats, primary data. So if you're looking at this one, basically you're looking to come up with a way to collect data to answer your hypothesis or answer your question. So a survey's sort of the logical, easy way to, probably the easiest, most logical way to go. But you can also do something like develop an experiment or an opportunity for observation that will allow you to collect the data. I had a student a few years ago who was very interested in curling. She knew she was going to be in the curling rink a lot in the 2 weeks in early January, preparing for curling season. And so her thesis was that given the opportunity, male skips will take a more aggressive line than female skips will. And so she basically, whenever she was off the ice, she was just observing various opportunities that various opportunities teams had, and try to determine whether a male skip would be more likely to do a takeout when there was also an opportunity to draw, to a better position. And then when while she was actually playing as well, she was doing the same thing, just kind of noting what her opponents were doing. Considerations, and this I sort of said in the previous one as well. While your main purpose is, of course, to prove your thesis if you can, or disprove your thesis if that's the way it works out, that's perfectly legitimate. Or answer your question, you do want to remember this is a math course, and so if you can pick quantitative data or collect quantitative data instead of qualitative data, that would be a much more valuable thing for analysis later on. You can do the math on the numbers, you can't do math on non-numeric data. Things to look for while you're setting this up. You want to be careful to avoid bias and sampling techniques that lead to bias, basically. You want to make sure that the data you're collecting does kind of give you an opportunity to at least comment on, if not actually, at least, sorry. You want to make sure that the data you collect does pertain to your thesis, allows you to possibly at least make decisions about your thesis or your question. It could be that, of course, once you see the data, it doesn't help, but you want to make sure that you're sort of setting yourself up for that opportunity at the very least. You're going to create graphs and tables to organize and clarify data. You want to make sure that they are appropriate. You're not trying to make a scatter plot using a single variable, for example, because that's not the way they work. You see that later on, scatter plot to variable right here. And whenever possible, you'd like to make sure that you have at least some indication of the math that we did. Again, single variable data, central tendency can be done, standard deviation, and so on. If you have two variables that are working together, a scatter plot with regression and predictions, very good idea. Certainly would look impressive. And then just the idea that correlation versus causation, if you do get to the point where you have a couple of scatter plots and there seems to be a correlation there where the two graphs seem to trend similarly, be sure you're sort of considering the possibility that there is a cause there versus just a correlation, or that it is just kind of coincidence. Project 3, probability casino game. This one's fairly simple. I think you're looking to design a new game for the casino. You can use dice, cards, spinners, anything that determines luck that you can determine would be fine. And that's sort of the idea of casino games, of course. They are basically just luck. The casino wants to take the skill out of the game because they don't want people to become good, because if people become good, they can become winners. So considerations, I just put, well, it'd be really nice to come up with a fantastic new game that you could actually market. It's probably not going to happen. I commented before that making sure your game is playable is important. But if you do get to the point where you're sort of thinking, oh, here's a nice game that's really easy to play, but there's not a lot of math that I can show Mr. Allen, you probably want to lean towards making the game a bit more complicated, and so that the math you can do actually, takes you somewhere a little bit further. So that's basically all this says here. That is to say, make sure I can understand your game, but that it still shows some work on your part. Don't make it I'm going to roll one die and pay you $10 for a 1 and $20 for a 2 and $30 for a 3. Well, that's not a very good game anyways, I guess, because the casino is pretty much going to lose unless they charge you, $40 to play or something like that. So keep it relatively simple so that it's understandable and so that you can play it in the simulation part down here. But at the same point, make sure that you're showing me that you do understand the math as well. This is the probability project, so it's definitely not, it's meant to be the mathy project. The things you're going to be doing, basically describing your game, make sure that it's understandable and it is playable. Calculate the various probabilities. So, and I don't know how this would be a problem, but make sure that whatever you're doing is something you can actually figure out. If you're dealing with cards or dice or anything like that, it shouldn't be an issue, but I just thought I'd include it. You'll want to be able to calculate, and this will be the sort of the biggest part of this, calculate the expected value for the game. And just to clarify, that's the expected value for the player, but the idea is that the player should be making less money than he's spending. So if I'm betting $10 and I'm getting back, say $6 on average, that's good for the casino. If I'm paying $10 to play and I'm getting back $12 on average, then that's not good for the casino. And the suggestion was that you may want to look up some expected value for popular games like craps, blackjack, and roulette to get an idea of kind of that sweet point where people will keep playing because they get back enough money to keep playing. But at the same point, the casino overall does better. If you're playing a game and you never win, you're not going to play very often and that game's not going to do very well. If you're winning enough to kind of encourage you to keep playing, not you necessarily, but if somebody's playing enough that if they're winning enough that they're encouraged to keep playing, then they might continue to play and continue to lose over time, which is good for the casino. And then again, sort of one of the things that I said you'll need to do is run a simulation for your game to calculate kind of an experimental data. to collect experimental data. So make sure that you can either find someone to play against or to play your game if you're playing as a dealer or something, or you can do a simulation in a spreadsheet that will do the same thing. And project 4, the book report / story review here. There's a book specifically that I'm suggesting we take a look at, and it contains quite a few good sort of 2 or 3 page, I'll call them stories is probably the easiest way to explain it, where the author kind of explains how sort of probability and randomness are confused in in our society, I guess you could say. So considerations, you're not expected to read the entire book. From the topics below, you'll basically choose 3 and you'd summarize the story. And then again, sort of this is a kind of mathy part of the project. So if you can, you're going to show any calculations or run a simulation supporting or disproving the claims of the author. So basically, something like the Monty Hall problem, essentially you're going to try to explain it better and show either with a diagram that you create or by doing the probabilities in a more mathematical sense that the author's claim that switching, and if you read it you'll understand better, switching is the more profitable choice. And so it's you'd have to read it to actually have an idea, or look it up online elsewhere to have an idea of what we're talking about. But that's kind of the idea. In the lottery section, they talk about a few things that have happened with the lottery that seem to be kind of crazy improbable. And you'll sort of do the math to explain the situation, then do the math to show that it maybe wasn't as improbable as we thought, and so on and so forth. Now, if you do this, and I do think it's the most interesting of the projects for sure, unless you come up with a fantastic, really interesting idea for one of the first few. If you've chosen any of these options and you're sort of unsure about whether the math is doable or not doable, make sure you contact me. I've read through the book multiple times, and I feel like there's something in all of them that we can probably do. If you kind of get hung up and say, what would you want me to show you mathematically for the hot hand fallacy? I'll go back and reread it and kind of give you an idea, or I'll say, oh, I guess there's really nothing there that we can kind of do, and I'll let you off the hook on that one, but you can still sort of submit it as just the summary of the story / concept. So this one's going to require a little bit more interaction probably, because you may need feedback on some specific topics. As I said, I think it's the most interesting one because I really think this book is fantastic, and I hope some of you do choose it. The other ones certainly are a little bit, I don't know if easier is the right word, but easier to do without any interaction. Of course, the very first one was just a regular old project that you've done 100 times in high school. So we're going to stop there, and good luck. You'll have a couple of weeks to finish this up. I guess I don't need to say all this because I'm going to cut it off anyways. Bye.